what I said, if the OH group of carboxylic acid is replaced by the halogen, it can be chlorine, bromine, iodine, then that is called alkanoyl halide. And if the OH is replaced by NH2 group, then it is called alkane amide. Alkane amide. Okay. So in this chapter, as I told you, main is three family: aldehyde, ketone, and carboxylic acid. And carboxylic acid, when react with halo acid, we'll discuss afterwards, we'll get this family, alkanoyl halide. And if we replace the OH group when it is react with ammonia, then we get amide. Okay. So these are the families we are going to study. Even two more family which we have done already in alcohol chapter. One is ester. In ester, what will happen? Again, the same thing. In carboxylic acid, if the OH group is replaced by OR, then it is called ester. IUPAC name of ester is alkyl alkanoate. Alkyl alkanoate, IUPAC name of ester. And last, in carboxylic acid,
OR dash
it can be dash, means alkyl group may be same, may be different. Okay, Raja?
Yes, ma'am.
Alkyl group may be same, may be different. Okay. And last is two molecules of carboxylic acid. So if you take two molecules of carboxylic acid and on heating, same thing, it may be same carboxylic acid, it may be different carboxylic acid. But if we heat this carboxylic acid, on heating, what will happen? Water molecule is being removed. Dehydration reaction will take place. Rest of the part is going to combine. That means R, C double bond O, O, C double bond O, R prime. This is called acid anhydride because water molecule is being removed. That is called acid anhydride. Okay. So again, I'm repeating this part. Main thing is aldehyde, ketones, and carboxylic acid. From the carboxylic acid, when carboxylic acid reacts with halo acid, we are going to get acyl halide. This is common name. IUPAC name is alkanoyl halide. If carboxylic acid reacts with ammonia gas, then we get amide. IUPAC name is alkane amide. When carboxylic acid reacts with alcohol, this was already done. Then we get ester. IUPAC name is alkyl alkanoate. And on dehydration of carboxylic acid, maybe same molecule or different molecules, we get acid anhydride. So these three family, the one I'm putting cross, against it. This family is basically we get it from carboxylic acid, right? So IUPAC name and all those things is clear, everyone?
Yes, ma'am.
Okay. Now, please, these two, the one which I'm marking, salicylaldehyde and cinnamaldehyde. See the structure, you need to know the IUPAC name of salicylaldehyde and cinnamaldehyde. It's a very, very common question of IUPAC system, or you can say in CBSE. We might ask you, what is the IUPAC name of salicylaldehyde? That means you need to know the structure as well as you need to know the IUPAC name. Anyone, can you tell me? Let me start with Sneha. Sneha, can you tell me what will be the IUPAC name of salicylaldehyde? Sneha, Ankita. Neha, Ankita, anyone, can you tell me? Or Raja, anyone? Kushi,
Ma'am, what is the question?
what is the IUPAC name of salicylaldehyde and cinnamaldehyde? Kushi, can you answer? Trisha? At least
Ma'am,
yes.
1 minute trying. Ma'am, trying 1 minute.
Okay, try. Yes, Rupam. Rupam has written almost correct. Almost correct, Rupam, but there's a small mistake. So salicylaldehyde, Rupam has written already. I'm writing behalf of Rupam. Rupam, it is 2-hydroxy benzaldehyde. I hope by now all of you could remember CH and OH. CH will get the priority. That's why CHO group with benzene ring, benzaldehyde, and hydroxy group is the prefix group. Okay, 2-hydroxy benzaldehyde. Yes, Sejal, correct. Very good. Yes, Rupam also corrected afterwards. 2-hydroxy benzaldehyde. Cinnamaldehyde, all of you try. I'm giving you 2 minutes time. And after that, valine, you are going to tell me. 2-hydroxy benzene. Please write down this IUPAC name in your book or your copy. Very good, very good. Sujan has written already for cinnamaldehyde. See, children, everyone, if you could remember, very good. If you are forgotten, please check. Please remember, since the aldehyde group is in the side chain, okay, so we have to give the priority to the side chain, okay, and benzene will be treated as a prefix or side chain. So now third position you have the benzene. So 3-phenyl benzene, whenever treated as a side chain, we call it phenyl. 3-phenyl prop 2-in-1-L. 3-phenyl prop 2-in-1-L. Okay, now last, all of you are going to try valine. Valine, let me start the numbering for you all. You have to just tell me the naming. You can write in the chat box. I'm giving you 2 minutes time. Sneha has written, Sneha, maybe the spelling is wrong. Anyway, it's Okay. Now everyone, all of you check. This one is methoxy group and this one is hydroxy. So alphabetically, which one will come first? Hydroxy or methoxy?
Methoxy.
Hydroxy.
Hydroxy will come first, is it?
Hydroxy.
So name of this compound is 4, H is capital, 4-hydroxy, then 3-methoxy, and then benzaldehyde. Please, you have to remember the structure of valine, salicylaldehyde, and cinnamaldehyde. Okay, everyone? After that, we have nomenclature part. See, the nomenclature part already it's done, isn't it? Now, straightaway I'll give you question answer to solve. See, these are the common name. Acetaldehyde, benzaldehyde, common name, but IUPAC recognized. This one, I think all of you know by now. IUPAC name of this compound is ethane 1-Al. Now, everyone, see, beta-bromo butyraldehyde. It's a common name. Please write down the IUPAC name of this compound.
Ma'am, what's the IUPAC of PAC name of benzaldehyde?
Benzaldehyde, as I told you, Sejal, benzaldehyde is the common as well as IUPAC recognized name. Okay.
Okay, ma'am.
You have to do this one, beta-bromo butyraldehyde. This is a common name. You have to write the IUPAC name of this compound.
Ma'am, once can you scroll up?
Up. This one you want?
Yes, ma'am.
Okay. Complete this one. And Mahek, I think I'm audible. Mahek, you are going to write the IUPAC name of this compound which I have marked. Sejal is done. I'll scroll up now.
Yes, ma'am.
Everyone do the IUPAC name of this one. Mahek, if I'm audible, please write down the IUPAC name. Ankita. Am I audible, Ankita?
Yes, ma'am.
Okay, so try the IUPAC name and write down in the chat box. Anyone? Okay. Ankita has written already. Ankita, there's a small mistake. Rupam also. See, you all are writing. This is a numbering 1, 2, 3, 4. Obviously, 3 bromo, then butan, correct? 1-Al. See, butan, an portion is not written in Rupam, Ankita, both of you. You have written but 1-Al. So you are not mentioning the bonding between the carbon atom. Is that clear, I hope now?
Yes, ma'am.
Okay. Next is ketone. See, these three are very, very, very important. Acetophenol, propionophenol, benzophenol. Number of times you are going to get these two questions. Okay. The IUPAC name of this compound, you all are going to write Acetone, I think all of you can write this one. Propan, 2-one. Now this one, see, benzene ring is treated as prefix. So where is the benzene ring? In the first location. 1 phenyl and 2-one. Okay, 1 phenyl ethane 2-one. Similarly, this one I think all of you can write yourself. Propiophenol. All of you try propiophenol yourself. Benzophenol I'll write again. Benzophenol I'll write. Propiophenol all of you write.
Ma'am, once show the previous page, no?
Yes. And
Ma'am, done.
okay. Now, everyone, please, propiophenol, you have to write yourself, everyone. Benzophenol I'll write, but this one all of you write, propiophenol. Anyone, can you tell me? Aishmita, can you tell me?
Yes, ma'am, trying.
Okay. See, exactly same. It's 1 phenyl ethane. Sorry, it's 1-one. I made a mistake. Children, please take this one. Take this one. It's going to be ethane 1-one. I made a mistake. I hope all of you can make out. It's going to be ethane 1-one. So obviously this one exactly same, no? 1 phenyl. Yes, very good, Shujan. 1 phenyl propan 1-one. Propan 1-one. Now, benzophenone, children check, there is only one carbon atom which is out of the ring. With one, 2 benzene ring are attached. So how am I going to try this one? 1, 1 diphenyl, di or bi both are right. Generally we write bi. Sorry, again I have written bi, it's di. Diphenyl. There is only one carbon, that's why methane 1-one. Methane 1-one. Okay, 1, 1 diphenyl methane 1-one. All are written, everyone?
Yes, ma'am.
Okay, I'll scroll up now. See, for this one, already IPC naming is given, and by using the normal rule, you all can write. Only exceptional is this one. Whenever aldehyde group is attached with a ring, we call it carbonaldehyde, like benzaldehyde, isn't it? That's why it is cyclohexane carbaldehyde. This is an exceptional IUPAC naming. So this is important, which you have to remember. And there are two more which you have done. Yes, this one you have done in class 11 as well as in class 12. Whenever we cannot count all the aldehyde group in the same chain, then we ignore all and we count only the main chain, leaving aldehyde group. I hope it's visible to you all. Leaving the aldehyde group, we are counting only the chain because we cannot count all the aldehyde groups, right? And whenever aldehyde groups are not counted, please remember we write carbaldehyde. So here it is also propane 1, 2, 3 tricarbaldehyde. This type of questions are little more important because as you could make out, they are like little different from others. See this one you can say 4-nitrobenzaldehyde. As I told you, benzaldehyde is IUPAC recognized. Even you can write 4-nitrobenzene carbaldehyde. Both are correct. Whenever aldehyde group you are unable to count, that type we write as a carbaldehyde. Is that clear, everyone?
Yes, ma'am.
Ravanita, Krushi, Shujan. Okay, now out of this one, children, few common names is very, very important. Formaldehyde, acetaldehyde, valeraldehyde, acrolein. You need to know the common name as well as the structure so that you can write the IUPAC name yourself. Acetyl oxide. Okay, the one which I have marked, you need to know the common name as well as the IUPAC name. Formaldehyde, acetaldehyde, very easy. Only you have to remember that acetophenone, benzophenone, along with those, you have to remember valeraldehyde, which is pentanal basically, acrolein, prop 2-in-1-al, and acetyl oxide, 4-methyl pen 3-in-2-one. Okay, these three are very, very important. So this all about the IUPAC naming. Next, we move to the structure. See, when I'm discussing the structure, children, again, let me tell you, see, from here, the portion which I have discussed, IUPAC naming, surely 200% I can assure you that you are going to get question from IUPAC naming. That is 100% sure, right? Now, from structure of carbonyl group, you are not going to get any single question, but you need to know to understand the reactions. See, if I write the carbonyl group, all of you could make out the carbon is attached with 3 sigma bond because double bond means one is sigma, one is pi. I hope all is known to you. One is sigma, another one is pi. This one is also sigma, this one is also sigma. So, Ankita, can you tell me what is the hybridization of the carbon? sp2. That means it must have a planar structure. So see, they're trying to make you understand that carbonyl part, this part is on the plane and this pi bond is above the plane and below the plane. Pi cloud is above the plane and below the plane. So obviously bond angle is 120 degree, right? And another important thing, children, when I'm talking about carbonyl group, we are talking about C double bond. Whenever it is attached with hydrogen, we call it aldehyde. And if both the part attached with carbon ketone, one is attached with carbon, one is attached with OH, then it is called carboxylic acid. All the cases structures are same. Now, this is your homework. All of you are going to solve it and you are going to send it to me in your, you can send it, don't send in the group, you are going to send it in the WhatsApp. Okay, send me personally. All these you are going to complete yourself. Okay. Now I'll start with preparation of aldehyde and ketones. And the best part, children, you know, most of the reactions already we have completed. Okay. Now from where you have to get it, I'll tell you as well as I'll make you understand that this part is already done. See, how many of you can tell me? I'm writing the reactions. Children, you can write in your copy or you can write in your book.
Ma'am,
Yes?
ma'am, can you wait for 2 minutes? My battery is gone, so I'll just charge.
Okay. Do it fast, okay? And then this one, since it's already done in term 2, okay, it's better you'll write down. Preparation of aldehyde and ketone. First, we are going to prepare aldehyde and ketone from alcohol. Let's see how many of you could remember this one. You have to tell me, it is primary alcohol or secondary alcohol? This one? The alcohol which I have written, Sujan, tell me, is it a primary alcohol or secondary alcohol? Primary alcohol. Now, primary alcohol, I have to get aldehyde. Could you remember which oxidizing agent I have to use, strong or mild? Primary alcohol, and I have to use the oxidizing agent. So which oxidizing agent am I supposed to use, strong or weak? Anybody? Kushi? Generally, which oxidizing agent we use? Kushi, am I audible?
Yes, ma'am.
कौन सा ऑक्सीडाइजिंग एजेंट यूज करूंगी? करना
Ma'am.
चाहिए हम लोगों को स्ट्रॉन्ग। देखो, if I use strong, alcohol gets oxidized. Please remember, if it's a strong oxidizing agent. Of course, all of you are going to write it down this part. If it is not, like I could make out, many of you have forgotten. Actually, what you all have done, basically you have memorized and vomited your copy and then you have forgotten. And okay, please write down. If you have 1 degree alcohol, this must be written. You write in your copy or book. It's up to you, but I want to see whenever you come for your physical class. 1 degree alcohol, strong oxidizing agent. Okay, you will be getting first aldehyde, but you will not be able to stop the reaction here. It will convert into carboxylic acid. So please remember, this is the method to convert 1 degree alcohol to carboxylic acid, because you have carboxylic acid in the syllabus also. So if you use a strong oxidizing agent, we'll be getting straight away carboxylic acid. Now, name of the strong oxidizing agent. Number 1, K2Cr2O7, of course, in presence of H2SO4. Even we can use KMnO4 in presence of H2SO4. These are strong oxidizing agents. Even you can use chromic anhydride chromium anhydride. This is a strong oxidizing agent which can convert 1 degree alcohol to carboxylic acid. But to convert 1 degree alcohol, you need a mild oxidizing agent, right? To stop the reaction in between, that's it, aldehyde. Now, name of the mild oxidizing agent. Mild oxidizing agent is how many of you could remember the full name of this compound? Let me see. PCC in CH2Cl2. What is PCC?
Ma'am, that one, no ma'am. Pyridium, ma'am, something like that.
Pyridinium chlorochromate. Pyridinium, P-I-N-I, pyridinium chlorochromate, PCC. Generally, we use PCC or we use this PCC. This one is also known as, please remember, these are the names which are very, very important. Odis reagent. This is also known as Odis reagent. Okay. Another one is John's reagent. Now, what is John's reagent? John's reagent is CrO3 chromic anhydride in presence of H2SO4, and this must be present in acetone, aqueous acetone. This is called John's reagent. They comes under the category of mild oxidizing agent. They stop the reaction in between. So 1 degree alcohol converted into aldehyde. Everyone clear there? I hope it's clear.
Yes, ma'am.
Next is how to produce.
Ma'am,
Ah,
scroll, ma'am.
no,
Not written.
1 minute. Once it's done, quickly tell me, okay, Rupam? Okay, so I have written 1 degree alcohol. Prem, am I audible? Prem, Tanmoy, Ashmita, can you tell me name of this 1 degree alcohol? What is the IUPAC name of this 1 degree alcohol? Ashmita,
Yes, ma'am.
name of this 1 degree alcohol? IUPAC name. Ethan, 1-all. And the aldehyde we are going to get, that is called CH3, C double bond O and H. Because what will happen? This part is being removed. Right? So ethane 1 all convert into ethane 1L. I hope now everything is written, everyone.
Yes, ma'am.
Okay, so now we'll go for ketone. Here it's coming down. Now for ketone, which degree alcohol we have to take? To get ketone, which degree alcohol?
2 degree.
2 degree alcohol. So 2 degree alcohol, IBC name obviously you could make out. Propan, 2-ol. Now you can use mild, you can use strong, doesn't matter, any oxidizing agent. Okay? Any oxidizing agent, like you can use A2Cr2O7 in presence of H2SO4. Generally, we use the strong oxidizing agent. Okay, even you can use the mild also, doesn't matter. That will give us same thing. Hydrogen will come out, so obviously we'll get propan on. So alcohol can be converted into aldehyde and ketone as well as carboxylic acid. Basically, I'm discussing right now aldehyde and ketone, carboxylic acid I'll be discussing separately. Now you have to answer me this one. Sujan, you tell me. Name of the reagent for this conversion. Sujan.
Ma'am,
Name of the reagent. Loudly. KMNO4 in presence of acidic medium. Any oxidizing agent? A2Cr2O7 in presence of H2SO4. You can use PCCN, CH2Cl2, anything can be used, okay? Done, everyone, then? Another reaction already you have studied to get ketone from another reactions already you all have studied, that is from alcohol only, that is the dehydration reaction of alcohol. This one also you have studied already. I'll give you the example, all of you see whether you could remember or not. Primary alcohol, when heated in presence of copper at the temperature of 573 Kelvin. This you all have done already. 573 Kelvin dehydrogenation reaction. Sorry, It's not dehydration, dehydrogenation. Dehydrogenation reaction will take place. Dehydrogenation. Dehydrogenation reactions of alcohol. Dehydrogenation means obviously you could make out 1 degree alcohol. Obviously the product is done. Similarly, if I take 2 degree alcohol, then what will happen? Anyone? 2 degree alcohol? Rupam, what will happen if it is 2 degree alcohol? Rupam?
What, ma'am?
If I take 2 degree alcohol, same reagent, then what is the product am I going to get?
Ma'am, ketone.
Ketone. So 1 degree alcohol on dehydrogenation reaction, that means in presence of this reagent will give us aldehyde, and 2 degree alcohol is going to give us ketone. So these are the reactions, children, already you all have studied, isn't it? Now we are going to start the reaction which is new. These 2 reactions we have already completed. Okay. Now I'll show you the book once. So see the first one. By oxidation of alcohol done, by dehydrogenation of alcohol done. Now from hydrocarbons, this reaction basically you all have completed in class 11 from hydrocarbons. Okay. So I'll show you the reactions again. All of you check whether you could remember or not. For that, we use alkene. Now, children, alkene, I'm not writing the side part because that will remain intact when it is react with ozone. If it is react with ozone, if you could remember class 11, you have done a house-like structure, heart-like structure, better to say. This is called ozonite. Side chain remain intact. I hope am I audible to you all? In presence of alkene, when react in presence of ozone, from ozonite. This ozonite, when react with zinc dust and water, see, this get dissociated like this. That means carbon is left out with how many bonds? 2 bonds, which was present in the alkene itself, and it's got attached with an oxygen bond. So it will represent like this way, double bond O. Because carbon has 4 bonds. So what has happened? I'm repeating again. You check what has happened. It's getting broken like this way. So carbon-oxygen bond remain intact. Okay. So how many molecules you are going to get? 2 molecules, and this oxygen will produce hydrogen peroxide. Okay. Is that clear, everyone? Why I did not write the side chain? Check. If it is hydrogen, it will remain as hydrogen. It will give us hydrogen. So we'll be getting formaldehyde. If one is methyl group, one is hydrogen, that is remain intact. There is no change in the side chain. So remain as it is. Okay. So what has happened? We are getting formaldehyde and acetaldehyde. If, say, for example, they are ketone, say both are methyl group, we would have been getting the ketone only. And the best part is, children, all of you see, if I remove the oxygen, I'm getting back the alkene again. If I remove this part, see, I'm getting back the alkene again. So how to get the aldehyde and ketone? Double bond को सर बीच में से तोड़ दीजिए. It will join with the oxygen. Okay, it will join with the oxygen and we'll get aldehyde and ketone. So from here, two types of question used to come in class 11 as well as in class 12. We might get the same thing. That aldehyde and ketones are given. We might ask you to give the structure of alkene or vice versa. Alkene is given, and what we have to do? You have to get back the alkene. Aldehyde and ketone. Okay, is that clear, everyone? Is that clear? This reaction? Give me a thumbs up, please. It is clear to you all. Please give me a thumbs up so that I can make out. Okay, okay. Sujan, Rupam, I'll scroll up then. Is it written?
Ma'am, once wait, no.
Okay. And I'll be checking your copy or book, okay? And please write it down. Wherever you are writing, you have to show me your copy. And I'll give the homework also. You have to practice all those things. I'm coming from washroom, okay? সুস্মিতা, হ্যাঁ শরীর ভালো না? ঠিক আছে ঠিক আছে ঠিক আছে। Okay. So I think this is written no. Now, after that, the next reaction, which is again another important one. This also you have done in class 11. Whether you all could remember or not, I don't know. Anyway, see, you have done this one in class 11 alkyne hydrocarbon chapter. Common name of this compound is acetylene, or you can say ethine. This one, in presence of water and H2SO4, as well as HgSO4, it produces a compound which is called in and all. See, one of the double bond is going to, out of two I bond, one is going to break. With that, H and OH is going to attach. This is called enol. There is a double bond as well as there is an alcohol. So common name of such type of compounds are enol. This enol further rearrange, which is called tautomerism, further rearrange to give us aldehyde. This is called tautomerism. I'm writing above here, huh? TAU tautomerism, or tautomerizes to give us. See how it's going to combine. This another pi bond is going to break. That will combine with this hydrogen. So C, another bond got broken. So now it has three single bond. Another single bond with another carbon. This carbon attached with double bond and H. Children, I'm repeating again. Out of these two pi bond, one got broken, and with that, H and H being attached. This further tautomerizes, means rearrange. How is it rearranged? कार्बन जिसके साथ ऑक्सीजन अटैच है उसमें डबल बॉन्ड हो जाएगा. डबल बॉन्ड बिटवीन दिस टू कार्बन इज गोइंग टू ब्रेक, एंड जो हाइड्रोजन है ये वाला कार्बन के पास, नेबरिंग कार्बन के पास जाएगा. सो देखो CH3 हो गया, दो हाइड्रोजन पहले से था और एक मिल गया, एंड देन C डबल बॉन्ड OH. Okay, so this one it tautomerizes to give us aldehyde. Similarly, if you have any alkyl group attached already and you are using the same reagent, that is water, H2SO4 in presence of HgSO4, then all of you check it. How is it same thing? We'll get the enol, CH3, C. Now, please remember Markovnikov's rule. As per the Markovnikov's rule, what will happen? OH group will be attached to that carbon atom which has less number of carbon. So obviously, OH will be attached with the second carbon atom, double bond, and hydrogen will be attached with the first carbon atom. So further it will tautomerize to give us. So what will happen? This hydrogen will go to this hydrogen. So CH3, C double bond O, and then CH3. We are going to get the ketone. So acetylene will give us aldehyde. Rest all the triple bonded compound will give us ketone. This reaction also we have completed. I hope after this is done. Seja, is it written?
Yes, ma'am.
Rupam?
Yes, ma'am.
Okay. Tanmay? Tanmay, is it written? Okay. Now, these are the reactions which I have marked with red. Is very, very important and specific reaction. They are called name reactions. Scientist Rosenmund first time performed this reaction. That's why called Rosenmund reduction. What has happened? This is called benzoyl chloride. Chlorine is being replaced by hydrogen to give us benzaldehyde when it is treated in presence of palladium and barium sulfate. So specific reaction you'll have to write and memorize. Another very, very important reaction which is first time done by Stephen. In Stephen reaction, alkane nitrile, okay, treated with SnCl to HCl to produce imine. This compound is known as imine, which on hydrolysis give us aldehyde. So this is also another important name reaction. Now, see, every cases we are doing the reduction. A very important reducing agent is diisobutyl aluminium hydrate, dival H. Very, very important. I hope all of you are marking in your book. Diisobutyl aluminium hydrate. This compound can convert alkane hydryl, any alkane to aldehyde group. I hope all of you could make out. It's a specific reagent, dival H, or you can write this way also. This is the same thing, aluminium isobutyl hydrate. Dival H, this one is same thing. They convert CN to CHO group. Not only that, ester group can also be converted into aldehyde group by this dival H. So dival H can reduce CN as well as ester to aldehyde group. This is very, very important again.
Ma'am, what is it? Dival H can.
Dival H can reduce CN group, nitrile group, and ester group. This is ester group into aldehyde. Understood, Rupam?
Yes.
Okay. Two more reactions we'll do. Again, specific reaction. How can we get the aromatic aldehyde group? See, this is another important reaction. It was done by scientist Icard first time. Icard used chromyl chloride. Name of this compound is chromyl chloride. Okay. Chromyl chloride in presence of carbon disulfide. Name of this is the solvent. This is solvent. Carbon disulfide. So chromyl chloride, when treated with toluene, we are going to get a chromium complex, which on hydrolysis gives us benzaldehyde. So children, these are the reactions you will be able to remember only if you write 2-3 times. Otherwise, it's very, very difficult. Same thing. See, This is called chromic anhydride, chromic oxide. This chromic oxide, when treated the toluene again,
Chromyl chloride, when treated with toluene, we get
no, chromic anhydride. This is chromic
anhydride.
oxide. Chromic oxide. Okay, chromic
Okay.
oxide. Second reaction. I'm talking about second reaction.
No, I'm telling about first one.
First
ma'am.
one. This is chromyl chloride. Toluene, when treated with, see here it's written. Chromyl chloride oxidizes the methyl group to chromium complex, which on hydrolysis gives the corresponding benzaldehyde. Okay, and name of this solvent is carbon disulfide. Now it's written, Rupa.
Yes, ma'am.
Okay. Similarly, this was done by Zeitard. And this one afterwards find out that toluene, even if you treat it with chromium oxide, and now what is the like solvent? Solvent is acetic anhydride. This is solvent, acetic anhydride. Okay, acetic anhydride. These are the solvent. When treated at little lower temperature, 273 to 283. Same thing, we are going to get chromium complex followed by benzaldehyde. Okay, this is called complex compound. It's called benzylidene diacetate. Benzylidene diacetate, name of this complex. On hydrolysis, give us benzaldehyde. Even toluene, if we treat with chlorine and brine, it produces benzyl chloride. On hydrolysis, give us benzaldehyde. This is another very, very important. See, these are the reaction, children. Straight away, you have to write and memorize. How you used to get benzene when treated with carbon monoxide in presence of HCl, we get benzaldehyde. Gatterman-Koch reaction. So we'll wind up the reaction discussing 3 more reactions. Okay, these are the specific reaction for the preparation of ketones. I think all of you heard about this compound. This is called Grignard reagent. Grignard reagent. When treated with cadmium chloride, we get cadmium. This one is called dialkyl cadmium compound. This is also an organometallic compound. This compound, when treated with acyl chloride, see, we are going to get the ketone. I hope it's clear. When acyl chloride is treated with dialkyl cadmium, from where we get the dialkyl cadmium? If it is treated with RNCX. Okay, so when we treat with, we are going to get the ketone. This one, CN means alkane cyanide. This is Grignard reagent. When treated with Grignard reagent, see the changes, children. What has happened? Triple bond convert into double bond. Triple bond convert into double bond. And in this carbon, see, it is C6H5MgBr. Try to understand the reaction. When treated with CH3, CH2, C triple bond N, one of the bond is getting broken. Carbon is getting attached with C6H5 and nitrogen is getting attached with MgBr. So you are getting this compound, double bond N, MgBr, and carbon is getting attached with C6H5. On hydrolysis, this part is being removed or replaced by oxygen to give us ketone. This reaction, number of times you all have done. When benzene is treated with alkyl or aryl halide, in presence of anhydrous Cl3, you know that this part will form acylamine, and this get attached with the benzene ring, and this chlorine form AlCl4 minus, right? So this is the another way which was first time done by Friedel-Crafts to form the aromatic ketone. Okay, so up to this we have completed the first one and the second one. These two is your homework. Okay, in text question, this one, you all do one thing. Okay, please write down in your copy. Okay, and what you all are going to do, you are going to send it to me as I told you. I've given the IUPAC naming, another one. This one. Okay. I hope everything is marked, homework and everything. Children, just give me a thumbs up whether everything is written or not. All of you, hurry up. Sejal, Rupam, Navanita, Navadipa. Okay. So what you all are going to do?